In this video, I will explain how to find the average cost function along with the minimal average cost. So let's jump into an example. This says, suppose a firm has the following cost function. C of x is equal to 40,000 plus 200x plus x squared. Find the production level that will minimize the average cost, then find the minimal average cost. So when we are given a cost function, like this function right here, here's how we can find the average cost function. The average cost function, denoted as c of x with a little bar over the c, is simply equal to the cost function divided by x. Now, the average cost function is minimized when the first derivative of the average cost function is set equal to 0. So let's start by finding the average cost function. So again, we're just taking the cost function and dividing it by x. So here's our cost function. We just need to divide this entire function by x. So we'll say the average cost function is equal to the original cost function divided by x. So we have the original cost function divided by x. Now, when we divide by x, we can divide each term in the numerator by x individually. So here's what that looks like. So when we do that, we'll notice that we can simplify a little bit. So in this term, these x's will cancel out. And in this last term, one of the x's in the numerator will cancel out with the x in the denominator. So we'll be left with 40,000 divided by x plus this second term is just 200, and then this last term is just an x by itself. So this is the average cost function. Now remember, we said we want to find the production level that will minimize the average cost. So the production level, in other words, the value for x that will minimize the cost, we can find that by taking the first derivative of this average cost function and setting it equal to 0. So let's go ahead and rewrite the average cost function. Now when we're finding the first derivative, it could help to rewrite this first term as 40,000 times x to the negative 1. And then we'll just write our other two terms as well, plus 200 plus x. So when we want to find the first derivative of this function, for this first term right here, we can use the power rule where we take the exponent and multiply it by the coefficient, and then we have to reduce this exponent by 1. So we would get negative 40,000 x to the negative 2. Now the derivative of 200 is just 0, and the derivative of x is just 1, so we'll say plus 1. So this is the first derivative of the average cost function, and we're just going to set that equal to 0, and we'll solve for x. So let's go ahead and move this 1 to the other side, and we can also rewrite this x to the negative 2 in the denominator. So here's what that looks like. We have negative 40,000 divided by x squared is equal to, when we move this 1 to the right-hand side, it becomes a negative 1. So we can write that as negative 1 over 1 if we want to. Now to solve for x, we can just cross multiply and set these values equal to each other. So we get x squared times negative 1, that's negative x squared, is equal to negative 40,000 times 1 is just negative 40,000. Now these negative signs will cancel out on each side. So x squared is equal to 40,000. To find x, we just need to take the square root of both sides. So we get x is equal to the square root of 40,000. That turns out to be 200. So the production level that will minimize the average cost is x equals 200 units. So when the firm produces 200 units, they will minimize their average cost. Then lastly, to find the minimal average cost, all we're going to do is take this 200 that we just found right here and plug it into our average cost equation. So we get C of 200. So the average cost when we're producing 200 units is equal to 40,000 divided by, remember for x we're plugging in a 200. So we get 200 plus 200 plus, again for x we're plugging in a 200. So 40,000 divided by 200, that comes out to 200. So we have 200 plus 200 plus 200, which is 600. And we'll say dollars. So the production level that minimizes the average cost is 200 units. And when we produce 200 units, our average cost is $600. And this turns out to be the minimal average cost.